Hi student, welcome to my YouTube channel. Today we start one new chapter and name of the chapter is circle. Name of the chapter is circle. And in this chapter we derive some equations of the circle. First equation is standard equation of circle. Second equation, that is the center radius form. And third equation, general equations of circle. So first we prove, you know about circle in 10th standard. So in 11th standard, we derive only the different form of the circle and equation of tangent to the circle, condition of tangency, director, circle. So first, today in the today period, first we derive here the standard equation of circle. So derive the equation. This equation is known as standard equation of circle. And question is, or theorem is, derive standard equation of circle, that is x square plus y square equals to a square, where a is radius of circle, where a is radius of circle. In this questions, we derive the equation x square plus y square equals to a square, where a is radius of the circle. So first we draw here the standard circle. We know that the definitions of the standard circle, a circle with center at origin is called as standard circle. So we draw here the circle proof. First we draw here the circle. This is x-axis, this is y-axis, here origin O. Origin is the center of the circle. Therefore, this circle is called as standard circle. And here we find the equations of this circle. So, suppose here we assume that let Pxy be any point on the circle. Pxy be any point on the circle. Then we joined these 2 points, that is O and P, we get the radius of the circle. OP is radius of the circle. And here it is given that A is radius of circle. So OP equals to A. And here O is origin, therefore coordinate of O 0, 0. Because O is the origin, and we know that the coordinate of the origin, that is x coordinate and y coordinate, is 0, 0. Again we repeat this. First we draw here the standard circle. Remember that standard circle, that is the circle with center at origin. Next here let Pxy be any point on the circle. Then we join OP, and OP is the radius of the circle. Because we know that the definition, that is the distance between center and any point on the circle, is called as radius. Therefore here OP is radius and radius is A. So write here A. And from this figure we prove these equations. That is the equations of this circle is x square plus y square equals to A square. So first we write here, in proof we write draw standard circle. Draw standard circle. First we draw here the standard circle. We draw here standard circle. Next, let Pxy be any point on the circle. Let Pxy be any point on the circle. Then OP is called as radius of circle. Join O and P, we get here line segment OP, and OP is called as radius of circle. OP, which is equals to radius, and this is equals to A, which is greater than 0. Then by using the distance formula, we find here a distance OP. Using distance formula. Using distance formula. Distance OP is equals to, when now that the distance formula, that is under root x2 minus x1 whole square plus y2 minus y1 whole square, where x1 y1 and x2 y2 are the coordinate of the line segment, coordinate of the endpoint of the line segment AB. Again we repeat this, distance AB is equals to under root x2 minus x1 whole square plus y2 minus y1 whole square, by using this distance formula. So we get here under root x2 minus x1, that is x minus 0, x minus 0 whole square plus y minus 0 whole square, by using the distance formula. But here a distance OP is equals to A. Here distance OP is equals to A. So we write here A. A is equals to under root x minus 0 square, that is x square, plus y minus 0 square, so we write here y square. Then here squaring both sides, squaring both sides, then we write here a square is equals to under root x square plus y square whole square. Squaring both sides, then a square, in the right hand side under root x square plus y square whole square. Then square and root cancel. Therefore here a square is equals to x square plus y square. Therefore x square plus y square is equals to a square, and this is the standard equation of circle with center at origin and radius is a. This equation is known as standard equation of circle. In this way we prove here the standard equation of circle. That is, the question is derive standard equation of circle x square plus y square equals to a square, where a is the radius of circle. Next we prove second form, that is the center radius form of circle. That is the second equations of the circle. So we prove here center radius form of circle. Center radius form of circle, and question is derive center radius form of circle. That is x minus h whole square plus y minus k whole square equals to a square. And here hk center of the circle and a is radius of circle. Remember this, where hk coordinate of center and a radius of circle. A is radius of circle and hk coordinate of center. So again we draw here the figure. We draw here the circle with center at hk and the radius is a. Prove. Coordinate of center hk, both that is x and y coordinate are positive, therefore our figure lie in the first quadrant. So we draw here the first quadrant. This is the first quadrant. X axis, here y axis, here origin O. Then we draw the circle with center at hk. This is the circle with center at chk, coordinate of center, that is hk. Again here we assume that let pxy be any point on the circle. Let pxy be any point on the circle. Then we join here cp, and cp is radius of the circle, and here radius of circle is a. So cp is equals to a. This is our figure, and from this figure we draw this equation, that is x minus h whole square plus y minus k whole square equals to a square. So again here first we write, we draw the circle, draw circle with center at chk and radius is a. So write in proof, draw circle with center at chk and radius a. This is given. Let pxy be any point on the circle. So we write here, let pxy be any point on the circle. Then we join here cp, and cp is radius. Cp is equals to, from figure, cp which is equals to radius of circle equals to a, and this is greater than 0. Then we find here cp by using distance formula. Using distance formula and find out cp. Using distance formula and find out here cp. Cp is equals to, again we repeat the distance formula. We know that the proof of the distance formula in 10th standard, that is distance AB is equals to under root x2 minus x1 whole square plus y2 minus y1 whole square. We use the same result here and we get here cp by using distance formula. Find out here cp, x minus h whole square, that is the difference between x coordinate, x minus h whole square, plus difference between y coordinate, y minus k whole square. So write here y minus k whole square. But cp is equals to a. Cp is equals to here a, that is the radius of the circle. So write here a, which is equals to under root x minus h whole square plus y minus k whole square. Then squaring both sides, a square is equals to under root x minus h whole square plus y minus k whole square, squaring both sides. Then here square and root cancel, therefore x minus h whole square plus y minus k whole square equals to a square, and this is required proof of the center radius form. This is again equations of the circle, and this equation is called as center radius form. In this equation hk, that is the coordinate of the center of the coordinate of center of circle and A is radius of circle. So this equation is called as center radius form, with center at HK and radius is A. So in the problem, if we give the center, then we find center and radius, then we find the equations of the circle. So in this way, we prove two equation or two form of circle. First is standard equation of circle and second is center radius form. Both these equations are very most important for solving the problem in circle. Okay, thanks.